Thank you very much for the introduction. Yeah, welcome to my presentation about printed sensors for structural health monitoring of composite components. My name is Ingo Wirth. I'm project manager for advanced printing technologies at Fraunhofer Institute for Manufacturing and Advanced Materials. I'm located in Bremen in the north of Germany. And we have 6 other locations in Germany, more than 700 employees and a total budget of more than 70 million euros. Yeah, the work which I present was done in the European project Morpho. And main aspects in this project was the monitoring and yeah, sensors which are embedded in parts and components. Why do we do this? The motivation was functionalization of smart structures for aeronautics. Yeah, using printed structures. So we use printed piezoelectric sensors for impact detection and printed thermocouples for monitoring of temperature changes. What you see here, you see printed thermocouples, or perhaps you don't see them so good because they're embedded in on the sample on the top. And on the other sample, you see printed piezoelectric sensors. I will go in more detail in the next slides. But first here, you see the screen printing process. This process was used to apply the piezoelectric sensors, which I show here. I don't want to go in detail because at this point, you see the principle on the slide here. And yeah, here you see the process in the lab. You see the screen, you see the paste, and yeah, structure printed on a composite panel. The structures which we print for the piezoelectric sensors on composite panels consist of a 3-layer structure. So we have a bottom silver electrode, we have a piezoelectric layer, and on the top we have also a silver electrode. Yeah, we also investigate the printed piezoelectric sensors. You see here the yeah, layer thickness of such a layer. It is 135 microns in the thickness, which you see here, which we investigated. And one important point is after printing, the sensors must be polarized because the piezoelectric material is unoriented, and use a polarization process to orientate the dipoles in an electromagnetic field. This means that we apply a voltage between the top and the bottom electrode, and then heat the whole sample up, and then the single piezoelectric crystals in the paste will orient. Yeah, after this, we do some measurements for check the repeatability and the reproducibility. And we see here that we check the capacities of the different piezoelectric sensors. We expect a capacity of 2 nanofarads, and we see for all sensors it is relatively close to this value. Then we did some tapping test results. So we connect the sensors to a digital oscilloscope, and then when we tap on the sensors, when we see a signal, and you see on the left side is a sample, is a very small sample. On the middle are the larger samples on the composite panel. We do also some impact tests with marbles, and yeah, here you see for 3 tests the signal, and the signal is relatively similar for all these tests. So this is what we also expect. And yeah, great advantage is that we can calculate an impact on a specific location on the sample when we have 3 different sensors, because we can calculate the signal time from the impact to the sensors, and when it is different for each of the sensors, and because they are on different places, then we have a time shift, and by using this time shift, we can localize the impact.